So well, here they say to us, it's given that the function of f is defined as negative ax squared plus bx plus 6. Now, furthermore, they say the gradient of the tangent to the graph of f at the point negative 1 and 7 halves is 3. So they give us the point of tangency, and they also give us the exact value of the gradient of the tangent, of course. So what they're asking from us is to find the values of A and B. And this is for 5 marks. Well, it's relatively a walk in a park because what we need to do here is to understand what is the meaning of the derivative of a function. So here they gave us that the function of f is defined as negative ax squared, and then we say plus bx and 6 there. That's fine. Now what they told us is the gradient of a tangent is equal to 3. What is the meaning of that? Or maybe I can say the gradient of a tangent is equal to 3. Remember, guys, what you used to say. Remember, every time you see f prime of x, you actually see many things. It's one thing, but it has many names. Now, the first name is the derivative of a function. The second name, it is the slope or the gradient of a tangent to the function at any point. The third name is the gradient of the function itself at any point. And of course, we also know that it's the instantaneous rate of change, but that one is not really applicable in this case. So we are given the gradient of a tangent, and now we understand that the derivative of a function is actually the gradient of the tangent. So it means our f prime of x is actually equal to 3. So that's the knowledge we are going to use. So this means the first thing we need to do is to differentiate the function. So this is what we get after differentiating. And then we equate the derivative to 3, right? So we say our f prime of 3 is equal to 3. And after equating the derivative to 3, we are going to substitute the x-coordinate of the point of tangency. So what they said to us here is that the point of tangency is negative 1 and 7 halves. So when we see x, we are now going to substitute negative 1. So what do we realize? Well, we have a single equation, yes, but this one equation has two unknown variables. Or maybe we can just say two unknowns. And immediately what crosses our minds is to use simultaneous equations. Now, if you say negative 2 by negative 1, you simply get positive 2. But then if you take this one to the left-hand side, well, it still becomes negative anyway. So every time you see B, you actually see 3 minus 2A. Now the question is, when will you get the second equation? Well, you are now going to use this point of tangency as any point that is lying on the function of f. In other words, you're going to use the fact that when x is negative 1, y is going to be 7 halves. So meaning you have 7 over 2, which is equal to negative a, into negative 1 squared plus b into negative 1 plus 6. So you still have your 7/2 here. And here you have negative a minus b. And this is added to 6. So you can call this your second equation. Then you take your first equation and substitute it into the second. In other words, every time you see b in the second equation, you actually see 3 minus 2a. And you say this is added up to 6. So now it's time to simplify. Well, we need to distribute the negative sign. And when we do, we get negative 3 plus 2a. So negative a plus 2a is going to give us a solid 1a. And negative 3 plus 6, it gives us a solid 3. So 7 over 2 is actually 3.5. And if you say 3.5 minus 3, you find that the value of a is just going to be 1/2. So now that we know the value of a is half, then what is the value of b? Well, b is just going to be 3 minus 1, which is going to give us a solid 2. So those are the values of a and b, such that the above mentioned conditions are satisfied.